In today's episode, Arjuna asks, could you please suggest an approach to forecast multiple targets? Is there a way to select multiple columns in IBM Watson Studio AutoAI? In our use case, we need to develop time series forecasts for multiple products. If we correctly understood AutoAI, it will allow us to select one column at a time to generate such a forecast. Is there an alternative to select multiple columns representing multiple targets? Thank you. Okay, so there's a lot to unpack here. One, AutoAI does not do time series forecasting. AutoAI does either regression or classification. So it doesn't support that at all. There are methods for doing time series forecasting. In Watson Studio, you'd want to use the SPSS modeler for some of that. Watson Studio AutoAI, out of the box, does not support multi-objective optimization. In fact, none of the AutoAI/AutoML family of technologies right now support multi-objective optimization. And the reason for that is AutoAI itself is fairly costly because the analogy I like to use is if you're baking cookies, these tools are essentially varying every possible oven temperature, every possible ingredient to see what the best overall cookie is. That is computationally very costly. Multi-objective optimization is also very costly, and it adds crazy amounts of dimensionality. The current technical name for it is Pareto multi-objective optimization. And if you think about two people playing tug of war, right? They're playing tug of war, and the little ribbon in the middle of the rope is the objective, right? And they're pulling back and forth. That's a good example of like single objective optimization. Somebody's got to win. Now imagine tug of war with three people holding on ropes, and there's still, there's things in the middle, and each one has a thing. And now there are 4 or 5 or 10 people playing tug of war, all holding different ropes. You can see how very, very complex this gets. Multi-objective optimization gives you many, many different scenarios to plan for, and then AutoAI has many scenarios of each scenario. So you can see how it just stacks up and becomes computationally unfeasible. The way we handle multi-objective optimization most of the time is doing what's called constraint-based multi-objective optimization, where you say there's guardrails. So in the marketing world, when we're doing SEO, we have keywords, right? And we have the volume of searches for a keyword. We have the number of likely clicks on that keyword. We have the cost per click if it's paid. And we have the difficulty we have to rank for a certain keyword. Trying to do a 4-way or 5-way algorithm to create the best balance of all the possible outcomes is really difficult because you have to compute every possible edge case. Sometimes you want difficulty 100. You'll never rank for this keyword. Well, that's not very sensible, right? Sometimes you want a $0 cost. Well, again, not necessarily all that realistic. So what as data scientists we'll do is apply constraints first into the data set before we do AutoAI on it. We'll say, you know what? I'm not willing to pay more than $7 a click, right? So that immediately knocks off a certain part of the table. I'm not interested in keywords that are, above difficulty score 50, because I know my content's not that good, so I'm not going to be able to really rank for stuff above that. So let's chop off that part of the table. I'm not really interested in keywords that have no search volume. We'll chop off that part of the table. And you can see we're starting to apply constraints to our data set first so that when we stick it into something like AutoAI, we already have a much more slimmed down data set where a single objective now makes sense, right? We'll manually look at the table and say, I want to optimize for clicks. Clicks is what I care about, traffic to my website, but I'm going to apply constraints manually on those other columns. I don't want below a certain volume or above a certain cost or too tough to rank for. And then that goes into AutoAI, and AutoAI, it actually makes AutoAI much more efficient because it has much less data to crawl through. So you would apply those constraints in advance. You can do this with multi-objective optimization as well. You'd apply your constraints first, and then in Watson Studio, there's the facility to use R or Python notebooks right within the interface. And so you can write your own code to apply using the multi-objective optimization library of your choice to do it there. So you could do that. That would not get you the auto AI capability, but it would let you do multi-objective optimization. You can also use the decision optimization or the Cplex facilities also within Watson Studio to do some of that if you're not comfortable coding. Again, it doesn't get you the auto AI capability, but it does get you the decision-making capability. Finally, on the topic of time series forecasting, time series forecasting is tricky in the sense that you need to do the constraints first, then you need to do the auto AI first, next to probably regression, either regression or classification, mostly regression, to figure out what you want to forecast, what is worth forecasting, and then you do the time series forecasting on that. So that's a 3-step process. You go from constraint to regression to forecast, and that's the process for that. That is not automated either. This whole question, this discussion is really good because it highlights the immense difficulty the data science and AI community is having with a lot of these automated AI solutions. They are good at very narrow tasks. They're good at one thing, but the number of techniques that you can combine that your human data scientist will know to combine and in what order is very difficult to put together in a machine. Just to have a push the button and let the machine do its thing. It will come in time, but it's gonna be a while. It's not going to be in the next quarter's release. Let's put it that way. So to answer your question, do your constraints, do auto AI to determine which feature selectors are the most relevant to your outcome, and then do time series forecasting. And again, you can do that in the SPSS modeler in Watson Studio, or probably you'll use a fancier library like any number of the Python or R libraries to really kick it up a notch after that. The good news is within Watson Studio, all of that, even though those are separate pieces of that can then be pushed to Watson Machine Learning for production use cases. But this is not an easy project, but it is an interesting one because you're really talking about the heart of making great decisions using machine learning. So good question. If you have follow-up questions, please leave them in the comments below. Please subscribe to the YouTube channel and to the newsletter. I'll talk to you soon. Take care.
Want help solving your company's data analytics and digital marketing problems? Visit trustinsights.ai today and let us know how we can help you.